Good morning, guys. Today we are going to solve a problem on heat transfer. See, that is in heat transfer. First problem we are going to solve is on composite wall. So determine the temperature distribution through the composite wall subject to convection heat loss on right side of surface with convection heat transfer coefficient H equals to 1000 watt per meter square degree Celsius as shown in figure. The ambient temperature is -5 degrees Celsius. Now this is what the wall given, figure is given. Now we have two materials, that is K1 and K2. K1 has 6 watt per meter square degree Celsius. K2 is 20 watt per meter square, 20 watt per meter degree Celsius. Now here K1 is one material, K2 is another material. He has not mentioned the material, but K1 and K2, it indicates that two different materials. H is 1000, T infinity, that means the surface is exposed to here. First thing you should know is how many number of nodes required for this problem. Because of two materials, I can take this as element 1, this as element 2. Now, because of this, here 1, 2 and 3, totally 3 nodes are required. Now, see, first thing you want to do it is model it into a FE model. See, all the values written, just given values you can write on it. Now I have taken this as a T1 because here on the surface temperature is 20, it is a steady state because of the constant temperature will be there on the surface. Now FE model 3 nodes, T1, T2, T3, T1 we know already given, T2 unknown, T3 unknown, we have to determine these two. Then it is exposed to a surface, that is fluid surface, that is convection, H equals to 1000 watt per meter square degree Celsius, T infinity at TA equals to -5 degrees Celsius. Length is given, that is 0.06, 0.02 meter. Now what is the one thing? See, always keep all the values should be in one common dimension. That I am keeping everything in terms of a meter. Now step 2, thermal conductivity matrix. See, first you should determine elemental conductivity matrix. How many elemental conductivity matrix you want to determine? Because of two materials, two elemental conductivity matrix. We know what is basic matrix, Ka, K into A divided by Le, 1 minus 1 minus 1 1. You know what is K? Thermal conductivity of the material. A is the area of the material. Le is the length of the element, and 1 minus 1 minus 1 1. We know area is not given. Assume area will be 1 meter square. Area will be 1 meter square. Now K1 is given, A1 is given, Le1 is given. Calculate what is your first material elemental stiffness matrix. What is first material elemental stiffness matrix? Just write it. K1 is equals to, that is K1 equals to, what is K1? K is given, what is K value? 6 into 1 divided by what is the value? 0.06, 1 minus 1 minus 1 1. If you calculate it, you are going to get 6 divided by 0.006 means you are going to get 100. That is the value will be 100 minus 100 minus 100 plus 100. Now what are the nodes? Nodes are belong to 1 2 1 2 because it is belong to element number 1. Now repeat the same thing for element number 2. What is element 2? Element 2 is one more K2 A2 divided by Le2 1 minus 1 minus 1 1. Now here A2 same thing, A2 will be equal to 1 meter. Area is not given, always assume area will be equal to 1 meter square. It is a constant. K2, what is the value of K2 given? K2 is given, K2 will be equal to 20 watt per meter square degree Celsius, 20 divided by into 1. What is the length of the element? 0.02, 0.02. Then 1 minus 1 minus 1, 1. Calculate it, you are going to get 10. 20 divided by 0.02, just check it, what is the value you are going to get it. Now here I think you are going to get is 1000. Now 1000 minus 1000. Okay, minus 1000 and 1000. Now this is belongs to what? Node 2 3 2 3. This is your K1 and K2. Now you got elemental matrix 1 and elemental matrix 2. Now what is next? Next, after this convection you should check it. See how many convection is there? Convection, it has been exposed. Where it is exactly it has been exposed? It has been exposed only at the node 3. That means what is your convection matrix? He will be equal to, what is He? He will be equal to A into H, elemental convective matrix will be equal to, generally while deriving I written 1001. Why I derive 1001? Because I have taken node 1, it is exposed to node 1 in the your derivation. But here in this problem, it is exposed to node 3, because of this 0 0 0 1 will be your matrix. This is your general matrix. Now if you check it, here H1, what is H1? Element 1, H1. See, H1 means element 1 is exposed to any fluid? No. That means here complete it is 0, 0, 0, 0. It is related to 1, 2, 1, 2. Why? Because element 1 is not in touch with any convective film coefficient. But when you come to 2, what is 2? 2 is in touch with your convection, A into H. That's why 0, 0, 0, 1. What is A into H? A will be equal to 1. What is H? 1000. Okay. 0, 0, 0, 1, then the value becomes 0, 0, 0 and 1000. That means this is belongs to 2, 3, 2, 3. See, sometimes you can directly write it. See, it is only acting at node 3. Because of this, the matrix will be 0, 0, 0, 1000. Because in textbooks, they won't give this. Directly, they will write H2 because where our convection is, the convection is occurring only at the node 3, occurring only at node 3, then what happened? It will become 0, 0, 0, 1000. If it is acting at node 1, then in this matrix, value will be here 0, 0, 0. That's it. Like that, you should calculate it. Then after this, what is the next one? Free end convection, force vector due to free end convection. What is that free end convection? Here also FH. Where is acting here? FH is acting in element 2 because it is exposed to, element 2 is exposed to your convective film coefficient. The derivation becomes A into H into T infinity. What is the answer? 0, 1. Why 0, 1? Because it is node 3. Because if you take 2 and 3, 3 is exposed to fluid. Similarly, if it is node 2, then 1, 0 it will come. Because of this, what happened? A into H, T infinity into 0, 1. Now substitute what is the value? A is 1, H is 1000, minus 5, T infinity 0 into 1. The value becomes 0 minus 5000. This is for element 2 and 3. What about element 1? See, element 1, directly write it. Element 1, it is 0, 0 because it is not in contact with any fluid. Now you got H matrix. Now you got your K matrices. You got FH matrix. But you should write it in the form of a global. What is the global here? See, FH global will be equal to, now write with respect to 1, 2, 3. Node 1, 2, 3. What is node 1, 2, 3? 0, 0 minus 5000. This is your global. Now similarly, what is H global? H global will be equal to, what is how many number of nodes? 3 nodes. What is H global? 0, 0, 0, 0, 0, 0, 0, 0, 3000. Why? Because it is acting only at the node 3. 1, 2, 3, 1, 2, 3. Okay, similarly, what is K global? K global will be equal to, or K will be equal to, now what is, there is no common. Now write it, you know how to write it. 1, 2, 3, 1, 2, 3. Now A11, 100, minus 100. 3, 1 is there, no 3, 1, no 3, 1. Then, what is the next one? K2. K2 is how much? K2 is here, I think minus 100 because symmetric matrix minus 100, 0. Next, if you come to here, this will become 1100. This will become minus 1000. See, from this, you can write it minus 1000 and this will be 1000. This is almost similar to your bar element. Now you got K global, you got H global, you got FH global. This also sometimes you write a K. This will write as a capital H. This will write as a capital F. Now, what is this? If you got all these three, now shift to your equilibrium equation. What is your equilibrium equation? Now write your K equation. What is K? K global already written. What is K global? K global will be equal to 100 minus 100, then 0 minus 100, 0. What is this? 1100 minus 1000 minus 1000 and 1000. Similarly, what is T? T is how many temperatures? T1, T2, T3. What is H? H is your convection matrix. What is convection matrix? 0, 0, 0, 0, 0, 0, 0, 0. This is what is the value? 1000. 1000 is the value. Correct? 1000 is the value. Sorry, this is 1000. 1000 is the value. 1000 is the value. Now, into T1, T2, T3. What is FH? FH will be equal to 0, 0 minus 5000. Why T equals T1, T3? Just observe how many temperatures? T will be equal to T1, T2 and T3. Now, what is the noun temperature from this? Noun temperature is T1 equals to 20 degrees Celsius. T1 equals to 20 degrees Celsius. Then what is the noun temperature? T1 is noun. T1 is noun means eliminate your first row and first column. Eliminate your first row and first column. If you go for eliminating first row and first column, then you should be careful. You cannot eliminate directly because there is a one term which is related to T1 is there. One term which is related to T1 is there. Because first row okay, but second row if you take it, what is second row? Minus 100 into T1 plus 1100 into T2 minus 1000 into T3 is equals to 0 or is equals to 0. Correct? Is equals to 0. Or before that, first you can combine these two matrices. Later we can go for elimination. Say first combine this matrix. T is common in both. 100 minus 100, 0. Then here minus 100, 1100 minus 1000. Why? Because here observe here 100 plus 0, 100 minus 100 plus 0, 0 plus 0 minus 100 plus 0, 1100 plus 0 minus 1100 plus 0. 0 minus 1000. But when you come to here, 1000 plus 1000, what is the value? 2000. 2000. Then what is common? T1, T2, T3 will be common. Then 0, 0 minus 5000. This is called your global matrix. Sometimes individually you don't write it. You can combine it and you can write it. Okay, before elimination you do this. Now what is common? See, before elimination, now if you observe here, there is a equation is there. If you observe this equation is 100 T2, sorry 100 T1, if you multiply second row, plus 100 T2 minus 1000 T3 will be equal to 0. Now if you solve this, what you are going to get? 1100 T2 minus 1000 T3 will be equal to minus 100 T1. Is it correct? What is T1? T1 we know that T1 is equals to 20 degrees Celsius. That means this equation becomes 1100 T2 minus 1000 into T3 is equals to minus 100 into 20 means minus 2000. Minus 2000. Now this is your equation number 2. Now if you apply this concept here, if you eliminate you this row and this column, why you are eliminating? Because you know that T1 equals to 28 degrees Celsius. If you eliminate this, see what happened in your matrix. See, your matrix should be written like this. What is that matrix? Your matrix should be minus 1100, correct? Because first row, first column is minus 1000, then minus 1000, 2000 into what is value here? T2, T3 is equals to what is the value? See, here you are writing minus 5000, but what is the value here? You should write here. You should write plus 100 T1. Why plus 100 T1? Just observe here. See, there is a value will be there. So if you bring it here, what happen? This will be, if you bring it this side, it will become plus 100 because this value will be there. If you multiply these two, you are going to get a value. But if you multiply here 100 into T1 minus 100 into T2, it will be T1 equals to T2 will become. Okay, like that it will. If you solve it, you won't get anything. If you have first column eliminated. But in second row, if you observe, there is a value is there. If your value is there, if you formulate this equation will be like this. Because of that, second row will be changed like this. What is that row? 1100 minus 1000 T2 minus 1000 2000 into T3 100 T1. This will be simplified like this: 1100 minus 1000 minus 1000 2000. What is T1, T2, T2? T2 I don't know. Keep it as it is. T3 I don't know as it. Keep it. What is 100 into T1? 2000. Because we know T1 equals to 20 minus 5000. Minus 5000. Now if you go for simplification, what is simplification? 1100 into T2 minus 1000 into T3 is equals to 2000 is one equation. Minus 1000 into T2 plus 2000 into T3 is equals to minus 5000. If you go for solving it, just check it. So what you want to make it? Multiply by 2 for this above equation. That will become 2200 T2 minus 2000 T3 is equals to 4000. That is minus 1000 T2 plus 2000 T3 minus 5000. If you solve it here, this and this will cancel. Okay, 2000. What does this will become? Minus 2200 minus 1000 means minus 1200 T2, that is plus, is equals to minus 1000. That is T2 is equals to, if you solve it, you are going to get 0.833 degrees Celsius. If you know T2 equals 0.833 degrees Celsius, substitute in any of the equation, you are going to get T3 will be equals to minus 2.916 degree Celsius. Now what is temperature distribution? T is equals to T1, T2, T3, that is transpose. Why? Because it is in the row wise. What is the value? 20 degrees Celsius is the T1, 0.833 will be your second temperature, minus 2.916 will be your another temperature. This is called your temperature distribution across the wall. Thank you.